Welcome to the second webinar about NMIS 9. Keith Sinclair, CTO of Opmantec, is here to take us through it. Thanks very much, Keith. Over to you.
Good morning and good evening, everybody. It's 6 in the morning here in Brisbane, and we're just going to kick off. We'll go through NMIS 9 and what's new about NMIS 9. We're just recapping that first one for anyone who's missed that first one. We'll keep that fairly brief and then move on into other exciting things about NMIS 9 and what it enables and the special capabilities that we get with all that data. So introducing NMIS 9, we've re-engineered NMIS 9. NMIS 9 is now on its currently been around, or NMIS has been around for about 21 years, and the architecture of the software has evolved steadily over time. The really big change for NMIS 9 is a new object model and an abstraction into MongoDB. That's the big change. That drove quite a lot of structural changes inside the code, and we've also been able to really eke out the performance and just make NMIS sing along a lot more with all of these extra capabilities. So why NMIS? Why NMIS 9? Why would you be interested in NMIS 9? NMIS has always had a sophisticated business rules engine. It has always worked out of the box. We've always made sure that NMIS just sort of started and you added some nodes and started collecting data, and that's still there today. It's like almost no setup required. You can download, install the software, installs itself, and then you can just add nodes and start seeing graphs. Visible operational impact is a really powerful capability. There's a traffic light in NMIS for the entire network. Summarizes it down into a couple of small panels that you can sort of keep an eye on to know what's going on. Automated health live baselining, so we're constantly comparing all the metrics against themselves. So this gives us a live baseline of how the network is performing, and that include the network including all IT resources and data center infrastructure. So you can be managing your servers and your routers and your switches and UPSs and storage and everything else. It's massively scalable. We have customers managing hundreds of thousands of nodes using NMIS and some of our commercial modules like OPHA. And we also support, we'll talk a bit about this later, we support horizontal and vertical scalability. So that gives us nice architectures that are able to be flexible for any sort of business use. Customizable alert escalation procedures, and this is a really, really key feature or capability of NMIS, and that's improved by using OP events, but the capabilities in NMIS are very, very good for this, and then they're just really simplified in OP events. But that ability to have an alert and then make sure that a human finds out about it through escalation. So quick timeline, I won't go through the entire timeline here, but back in, NMIS was basically born and released back in 1999. It was a response to a need. Well, basically a quick question to my boss at the time. I said, do you want me to buy something or build something? He said, well, why don't you do what you think is best? And I said, well, how about I do a bit of both? So I went and bought some commercial software to use at the bank at the time. And I also went and wrote NMIS, the version 0 of NMIS back then, and then released it to open source soon after. So then rapidly NMIS grew. There was clearly a demand for this kind of capability, and there was very few network management systems included in the open source available packages. A lot of them were more tools like MRTG, fantastic tool, but you really need to manage MRTG. So net result is we come forward, and Opmantec started in 2011 and NMIS 8 was released. NMIS 8's been a fantastic engine. It's really taken us, and all of our customers are very happy with NMIS 8. But during the last, I don't know, it was immediately being the guy who sort of started with NMIS, I'm looking at it and thinking of all the things that I can do to make it better. And so we sort of undertook to start NMIS 9 a while ago. The ideas for NMIS 9 have probably been around for 5 years or more, and then we started working on NMIS 9 in the background a while ago, and we released it on the 24th of June. So what's changed in NMIS 9 and why it matters? And this is really, really important because we a lot of our customers who use NMIS, it is about reliability of the platform, and is about scalability of the platform. And so we needed to really make sure of those things. And that scalability means many, many, many things. We need to eke out every bit of performance. I mean, we really are talking about race car performance, right? We're trying to get out that extra tenth of a second, literally getting a tenth of a second off a poll cycle when you're polling 3,000 or 4,000 nodes on a server, or 5,000 nodes on a server, makes a really big difference. That tenth of a second times 5,000 is 5,000 tenths of a second. So, enhancements to the engine. So we really, the NMIS engine is very powerful, and it is heavily optimized. And we kept the best bits, and we improved performance. So we kept all the things that were working really well, and then we just worked on making it faster and leaner and more efficient. We replaced MongoDB replaces the NMIS 8 file system. This is where we got a lot of flexibility and performance, and there's just a huge thing going on with having Mongo under the covers instead of a file system database. The file system database has done us really, really well, very powerful. I really cannot believe how well the file system database has worked. We just kept finding ways to make it continue to work, but we couldn't do things with it that we can do with MongoDB, and that's really critical. The ability that we've got now in OPHA to replicate data to all the servers, all the data in MongoDB gets replicated to the master, and that's a really amazing capability, which we're going to talk more about in a minute. And then, that last point is that, master server has more data available. So, and to do that, you install OPHA, you have a master server, and all the data from the pollers is available on the master, and you can, draw all your maps and see top end for the entire network. And again, we'll talk a bit more about that in a minute. So a little bit more details about enhancements to the engine. I won't go into the details of this. I'll sort of leave that there and just talk about some of these points, but leave that slide up so you can read through the notes there. But it is about the fundamentals of NMIS 8 were very solid. They could be improved, and that's what we focused on. The really big thing is MongoDB, as we just talked about, but the new scheduling system is a really big boon. So having that standalone daemon that runs itself, we're no longer relying on cron, and the standalone daemon runs and manages all of the threads. So that gives us very granular resource management on the server that you're running on. We won't, we use what's known as a pre-fork worker pool. It's a worker pool of threads, works in a very similar way to Apache daemon. So the Apache daemon starts a bunch of workers, and then they service all the web requests. Very similar conceptually to how the NMIS engine works. Each of the little workers sit there waiting for work, and then the scheduling system puts things into a queue and they process it. Really fundamental to how we've been able to work with NMIS 9 and improve it. And it changes the way you interact with the system. So it gives you asynchronous operations. You can ask the engine to do something, and then when it'll go off and do that independently and come back. And things will be just magically finished in the background. You're not blocking, waiting for things to finish. So MongoDB, this is probably again the biggest thing. It's a big data approach for all the node event and status data. Again, that big data approach is really, really critical. Now you can do questions and get a holistic view of all of the data. And really fundamental, we've changed the schema so that that's possible. But now you can, instead of just seeing the interfaces for a single node, you can see the interfaces for all nodes and perform queries. So you can really quickly, query for IP addresses or find all interfaces that match a certain criteria and filter those. There's a very, very powerful filtering engine, OP charts, and I want to get to showing that in a really quick demo at the end. And that's just a really, really powerful capability, and I probably can't talk about it now. The improved search, so you can search and you get these benefits when you're using OP charts, our commercial package, which includes dashboarding and maps. People love our maps. You can do topology diagrams, all sorts of things. So, the improved search is really important. And again, because everything's in a database, we can do those searches in milliseconds. We used to always have search and OP charts for NMIS 8, but when we couldn't do the things that we can do now, because now the data's in the database. We have reduced activity, more data in memory. This is a double-edged sword, but this is the trend for all modern software today, is to have more data in memory. And that's how we get performance. The more we use disk, the slower things are. We want more data in memory. And that's how we get a lot more performance. So what this all really means is that OPHA master server now has more data available. And why is that powerful? So we have better performance for the centralized data storage. So we can now, because the data is in MongoDB, all the data comes in from all of the pollers into a central database. And now, the master server can have access to all of that data. When we're looking, and the reason we did this is that people wanted those poller features that were available on a standalone server that worked beautifully. Things like top-end topology maps, interface and inventory search, those things are now possible on the master with thousands and thousands and thousands of nodes, tens of thousands of nodes. You can bring all of your nodes through to the master and do all of those things as if you were using a poller, and transparently the system just shows you the data. And when you want the live performance data, so the graph of something, the master goes and collects that data on demand and displays that for you. You don't know that it's doing an API call to get that data from the poller and deliver the detailed performance data to you. So it's very, very powerful capability. We do have the most recent performance data available on the master, and we use that for things like top end and so forth, and that's what we call the latest data. And then we have, and I just sort of talked about this already, but seamless access to the detailed performance data. Now, OPHA enables all of that. So OPHA is our high availability product. It supports multi-server and redundant polling. Redundant polling is actually being added to NMIS 9 right now. We couldn't wait to get NMIS 9 out, so we released it without supporting redundant polling. But redundant polling is being worked on, and it'll be delivered in the next coming weeks, probably before the end of August for sure. So why is all this important? It's all about the data. It's all about multi-server architectures. So the big thing that NMIS 9 helps us with is better multi-server architectures. We want to get to the point where we can be doing more flexibility, more things with our multi-server architectures. And we get driven to this from our customers. This is what our customers ask for. So NMIS 9 with OPHA delivers scalability and consolidation. These are two really critical things. What everybody wants to do is they want to be able to operate their network and get the visibility that we can deliver. And they want to do that on the smallest number of servers that they can, practically support. And there's some flexibility there we'll talk about in a second. But they also, so that's sort of partly scalability and partly consolidation. So they don't want to end up with unnecessary servers where they don't need them, but where they want to support maybe remote polling, where they want to have a poller at another data center or on a customer premise or something like that, they want to be able to do that as well. But ultimately, you want to be able to scale vertically. So you want to be able to have the maximum number of nodes that you can practically support on a given specification. So that's your scale vertically. And you decide what that, as an architecture and how you build out your virtual infrastructures. And of course, it has to be said, NMIS 9, all of the technology we're talking about, all runs virtual. You don't require physical appliances or physical servers. You can if you want, but it'll happily run in virtualized environments on a virtual machine. So you can scale vertically. So you might decide in your infrastructure that maybe a machine with 8 CPUs and 16 gigs of RAM is a really good target, which means you might need more servers to do that. That's fine. Or we've got some customers who really max out their NMIS servers, and they'll give them 50 gig, 100 gig of RAM, and they'll give them 32 processors and really big specs. So you can do that, and you can manage a lot more elements when you do that. So that's scaling vertically, and you scale vertically to the size that suits you. Then you scale horizontally. Now you add more polling servers, more things that you need to do the work. And so you can do both with our solution. And OPHA is the key to that, because it lets you do either. Really important here is that we don't charge you for additional servers, right? So if you have OPHA and 5 servers and 1,000 nodes, or you wouldn't need it for 1,000 nodes. If you had OPHA and 5 servers and 10,000 nodes, we wouldn't charge you extra if you wanted to have 2 servers doing that or 15 servers doing that. We don't charge you differently. We charge you on the node count. We think that's really fair, and it means that you can get your the thing that you want to do. So you can scale vertically and horizontally to suit you. And that's all about being able to consolidate all of that infrastructure, management infrastructure to the right size for you. It's about consolidating all of that down. And then, also providing that fabric for all the rest of the applications to use. So operational scale, we're really important about operational scale. We have what I'm terming a centrally managed distributed system. So this is what OPHA 3 is all about. We want to bring everything in. We've got this distributed system doing all the things it's got to do. And then we have these master servers that talk to the pollers, and the master server controls the distributed systems. So you go and work on the master server. Centralized node management is a really key part of that. That's going to be delivered as part of our redundant polling. This will be delivered in the next month or so. And that centralized node management means you go to the master and you edit and you manage nodes there. You don't have to deal anymore with going to each poller and adding nodes and deleting nodes. You're going to do all of that on the master, and the master will push the nodes out to the pollers. So you get the best of central, because distributed systems are awesome, but they're a bit painful because you've got to manage all these distributed things, right? We're going to give you the best bits of centrally managed by having a cluster, and then that cluster is centrally managed, and that cluster is a distributed system. So, giving you the best of both worlds. So the centralized management server management is also a really big part of that. So you go to that master server, you decide what configuration changes you want to make on the pollers, and you push those out to the pollers. Very powerful capability available right now in OPHA. So flexible scalability is the last thing. We sort of touched on this a little bit already, but you can start with one server, and you might decide to have one massive server and poll lots of nodes, or you might decide to start with servers across the country or across multiple countries, whatever it is that you need. And we've got customers running hundreds of polling servers, managing hundreds of thousands of nodes, in their environments. So we have the architecture to support the different needs. And there's more flexibility because you can still do things. Most of our customers will run MongoDB on the same poller, because MongoDB is also used by our other commercial apps like OP-config and OP-charts. Well, OP-charts uses it for some features, but it definitely uses it for lots of features now. And OP-events, for example, all really heavily use MongoDB for their own application. So if you needed to, you could split the MongoDB out to a separate server. So would have two servers, and that's another level of flexibility and architectural options. Or you can scale that server up to be a bigger server. And you can also use MongoDB clusters if you needed to have multiple clusters of database if you wanted to do that. So lots and lots of options around that to really drive the solution that you need. And we're happy to make recommendations on all of this. The big thing is keep it simple. Start with a couple of servers, figure out the scaling in your environment, and then figure out a good number for you, and then just add more pollers as you go. That's the simple way to do it. So let's talk about some of those architectural options. So here's an example if you're an MSP. I'll look at an enterprise example in a second. So you might decide to run a single data center. You might have multiple data centers, both are supported. So you would have pollers in your data center maybe, and then you might have customers who have pollers on-prem. So you have different customers and you can absolutely support those. You might be using MPLS or some sort of private network connection. And then all of those pollers are going to bring data back to that single pane of glass, a SPOG, single pane of glass. So you're going to get that master server as a single pane of glass for all of those pollers. You've got another option, and you can have both of these. It can be hybrid. You can do these in combinations. You might have some kind of cloud offering that you're offering customers where you've put your central single pane of glass into the cloud, the cloud, quote unquote, and you're running pollers in the cloud that talks across technologies like Amazon AWS Connect. So you have a private connection to your customers who are also running things in the cloud. And then, you can use a single pane of glass to go across the internet to a poller on a customer prem. So you can do this beautifully with NMIS 9 OPHA 3. This is available to do as a flexible way for you to run your MSP business. Very powerful capability, and running your equipment in the cloud and then managing cloud services. Everyone knows where the cloud's going. On-prem is still there. We still need on-prem. We're going to continue supporting on-prem. There's going to be lots of stuff on-prem for a long time, but cloud is where lots of people are putting their workloads, and we can talk to things in the cloud. We can manage things in the cloud. No problems at all. So large enterprise. So if you're a large enterprise, typically you're going to have, you're going to have 2 data centers or more. And again, similar to what we just looked at, you're going to have a single pane of glass with pollers. You might have regional pollers. So in Australia, we have a huge country, and we might have people in Western Australia. So we might have a poller over in Western Australia handling that local polling, keeping those latencies down, and it would report data back, to example, for a single pane of glass. Maybe that's back in Sydney, and there's another one in Brisbane here where I live. So you've got two data centers who are collecting data from all the pollers that are distributed, however you need them to be distributed, and we can support that. And we have customers doing this today. You know, one of our big customers runs data centers in London, West Coast US and East Coast US. They run a master in each of those, and they run many, many pollers for the different environments. And each poller talks to each master, collects data from each poller. So it's a very powerful capability. So when you go to any master in the network, you see the entire network. If you're in London, you can see what's going on the West Coast, and it's all transparent. And the staff just log into their local single pane of glass. Regional staff can then also just access that local poller if they need to. They're not interested in the rest of the world. They're interested in Western Australia. Beautiful place to be. You know, why would you want to look at anything else? So they just go to that local poller. So again, we've got those flexible architectures to scale to what you need. So, you know, what a lot of this is all about is about delivering new capabilities to our, helping our customers who love our commercial products. And OP Events is our very powerful event management capability, and it works beautifully sitting on top of, you know, and like a event management fabric. So some of these terms are funny, but you know, there's an event management option. So basically, those who aren't familiar with OP Events, it's a flexible event management tool. Very, very powerful. It'll take data from any source. So syslog, SNMP traps, application data. It'll actually natively handle NMIS events. And it's also got APIs that you can just poke events into it. It's got webhooks, quote unquote. So you can just poke events into it using an API call, RESTful API call. Very, very powerful. So that gen is identified, things are identified as an alert or something interesting that we want to do something with. And then we filter and correlate those, and we then deliver them to the GUI so that human can see them, or that you can get notifications. That's a really boiled down summary of how the system works. And we've got some really flexible event management architectures. So for example, it's looking similar to what we just looked at with that large enterprise. You know, you might run OP events on every single one of your pollers. So you might have OP events running on every poller. That means the OP events is running locally, and then you might run on the master servers alongside NMIS and OPHA. You might run another copy of OP events, and only the interesting events go through to the master server. This is a really, really powerful way to filter. So have the granularity that you need at OP events at the poller level. So all the details are there. You're not throwing anything away early. You're keeping it. All the details are there. And then you push the important events up to the master server. All right, so now you're sitting on the master server, you're looking at the events, and you can see where they came from. You can see which poller they came from. All the details that you need to handle that are on the master. And when you're using NMIS 9, OPHA, and OP events together, you've got more details about the node all locally. So you're not having to go and collect details from, more details. You just click transparently and go across to OP charts or OP config on the master, and you can see all the data that you need to see. And then you've got access to the event data coming from the poller. You can click and drill down into the details of that event, you know, out there on the poller if you need to. So this is a really powerful capability to manage your things. And I've shown there, it's probably a little bit, there's a NOC engineer over here in one data center. They're not looking at all the other systems. They're just using OP events on the master. OP events is the best way to deliver information to your NOC engineers. Very, very powerful capability, and really is the best way to give them the information they need, not flooding them with all of the details. And OP events on the poller then is what the engineers need to do what they need. And that regional engineer out in Western Australia, they're sitting there looking at that OP events in their region, handling what they need to see, and that's the view that they need. So this is a really, really powerful way to deliver the capabilities to the humans who need the data they need to do their jobs. And that's what it's all about, getting the data that people need to do their jobs. So a really quick case study, and then we'll dive into a bit of a demo. So we had a customer who, very large manufacturing company who has WAN services to many sites, huge network, tens of thousands of nodes in their network. And each of those sites, each site that they have has a WAN circuit. Sounds obvious, but they have a WAN circuit. So a really large distributed network. And they've got all these BGP peers and internet services and all of these different things going on. And that's how they manage it. So they sort of treat those WAN circuits as the business service delivered. And that's what the service offering, if we sort of look at ITIL and service catalogs, that's the service offering that they offer. And they have SLAs and so forth, and they need to meet those. So that's what they do. They abstracted everything down to these WAN circuits. That's the really critical thing. All those routers and switches and all those distributed layers and all of these different things boils down to a WAN circuit. Real wonderful simplification of a very, what can be very complex for many companies. So how do we do this? We take NMIS, polls for status of peers, response time, etc. We also deal with syslog events running on the server, and the WAN circuits events. So when a WAN circuit event, that's a BGP related event, and it's just a really specific subset of all the events that they're interested in. They don't deal with all of the events. They're there being processed, but they're focused, very focused around what they call WAN circuit events. So BGP peer down, for example. So when the WAN circuit event comes in, it's enriched by OP events with additional BGP peer data and all the other WAN circuit data that they need. So you don't need to go hunting for all this other information. All the information that you need to understand what's going on is there, and it's in the OP events panel, right? So then OP events also performs automated troubleshooting. So as that WAN circuit event comes in, it verifies things. So it sits there and it says, it's going to ping the node and it's going to verify other things that it can do depending on the type of event that's coming in. It's going to perform automated troubleshooting. Very powerful capability, part of Opmantic's operational process automation capability that's across our products. So OP Events does that automated troubleshooting, and all of that data is now in the context into the event context. So when you're looking at an event in OP Events, we call that page the event context page. It's all of the context related to that event. It's a really simple English wording, event context, but it's all context related to that event is in one view. I'm going to repeat that because it's really important. All context related to that event is in a single view. You're not hunting for information. Everything you need is at your fingertips. Everything we can cram onto that screen without overloading people is on that screen. And then at your fingertips is a click to more details. Click to go in to see performance. Click to see configuration. Click to see the event details. It's all, but everything you want to see, it's all in the control of you guys, our customers. You can control what you want to view on that page. And then what this customer did is then they put that whole event context automatically into ServiceNow. So they integrate when these WAN circuit things come in, a ticket is opened in ServiceNow automatically. It's all linked together. So ServiceNow knows which event created it in OP events. They use our APIs for authentication. So ServiceNow itself authenticates through to, and it's all single sign-on. So the username is passed through the system, but the user signed into ServiceNow, and then they're sitting in ServiceNow looking at their ServiceNow panel, and they go click on an incident they need to look into, and it automatically opens the OP events event context inside ServiceNow. I believe they're using iframes, but they open it up in an iframe inside ServiceNow. All the authentications pass through, and then now the operator is just, as far as they're concerned, they're just still in ServiceNow. They've never left. They're just seeing a very powerful capability that ServiceNow is delivering, which maybe isn't so good for us, but it is really powerful for our customer. And so why is this really good? Because the network operations team don't need to go and learn other tools. They don't need to think about anything else. They don't need to know about all of those detailed things that are going on in the background of OP events and NMIS and OPHA, all the things that it's doing. They're just very focused on working in ServiceNow and staying there. And all the detailed technical data they need to do their job is delivered to them in that event context page. Incredibly powerful capability. And, this is I help them with developing this capability, and and I'll be writing up I'm just so slammed with time, time poor at the moment, but we'll be writing up a bit of a white paper case study on this as soon as I find time to put pixel to screen. And a little bit more details about how that works. So basically, and you can do this yourself, and we've actually got all of this is now included in not all the detailed stuff with the WAN circuits, but so basically an event comes into the NMIS event log. We use an alternate way of processing events of the NMIS events, which is what we call our generic event parser. Very powerful capability in OP events, can basically process any log out there, any sys log, any application log can be processed by this thing. So NMIS events are then processed normally, and they just go through to NMIS and everything works normally. But if they're a WAN circuit event, they get handed off to an event plugin where we do an additional enrichment. This is essentially a database lookup. I mean, that they do it a little bit differently, but it goes off and goes and looks up additional data about that WAN circuit, matches the BGP peer ID, grabs out those BGP peer details, drops them into the event as part of the properties of the event. Then the whole thing then gets delivered through into the event. So now again, that event that's in OP events is enriched with all this additional data, and all the customer really has to do is they maintain. I believe all of this is their back end for all of this is ServiceNow, but I never quite found out where the data was coming from. But they maintain all of that data somewhere, and they just kind of get it available for OP events to consume, and then enrich those events. So that event enrichment is incredibly powerful. So I'm going to just jump over to a really quick demo of a few capabilities. I've logged into OPHA 3. We're sitting here having a look at OPHA 3. The first thing that you'll notice if you've been using OPHA is that we really simplify that front-end GUI. We're giving you the status of all your peers, so you can log in here and see what's going on, and you can understand who you're talking to and what problems there might be. So we can see here that Fuller, this is our lab network, so things will be read here that shouldn't be read. It's not a typical demo network. I'm using the development servers because it's we've got a lot more stuff in our development environment that we use, but it is a bit messier than our demo systems. So we have Fuller, one of the polars, and we have Polar 9, and then we have local servers. So really important, we sort of treat the local server like a peer. Well, it is a peer. They're all the peers. So it's a local peer and there's remote peers. It's a simple concept. So we can drill into those peer details. And we see that we've got 2 remote peers, and we can have a look at Polar 9. And then here's everything that's going on with Polar 9. And we've got just buttons here to enable or disable peers. We've got all of the things that are going on. This isn't something for that end user to ever look at. This is something for the application data. You can clear the latest data. You can pull the peer data now, and everything just happens transparently. It's really simplified how all of this works, and you can see what's going on. So let's just try it, because there's never the time like the present. So it's 38 minutes past the hour right now, and we just pulled the data. And we pulled all the data from that peer. We are looking at Polar 9, so we just synchronized all of that data in a few seconds. So you can see we grabbed node data in just under 2 seconds. We grabbed inventory data in just under 3 seconds, and all the details of everything that's going on is included. And what's really important with OPHA that I to probably talk about here now, we don't replicate all the data all the time. So you get all the data when you need to. So if you don't have any data, we send all the data. And then once you've got the data, all the data, we only send what's changed. So we send the deltas, right? And that means that we can really synchronize and keep a lot of data in sync, and keep that happening as needed. So, great visibility into what's going on with our polars. And if we go back to configuration, what we can do is how do we manage those polars? Let's go new comp file, and we'll I'm going to quickly try and remember the things. I'm going to make a config file for this. I'm going to be creating an OP common config file, and then I'm going to call that OP config. I'm just going to call it OP common message of the day. So I'm just going to set the message of the day. So basically, we would just change something. So if we just wanted to do the core, we just pick the section that we want. So let's just say we're going to do something with the NMIS. So we just get the bits we want. We don't need to go hunting for all of the rest of everything else. We just want to go and include the things that we want to include. So for example, this should say 9. And we're now going to just, and we want by default OP config to be activated. So we're just going to change that. And that's our little node skeleton. So now we save that. I go back to the cluster configuration. So now we're looking here and we've got our message of the day, which is poorly named. And now what we do is we apply that to the different groups of devices that we've got. So I want to send that to all polars, and I'll save. So now I'm going to send that to all polars. And when I'm ready, I can go ahead and push that out to all polars. And then that goes out, and we've got a lot of features under the cover that support this. So NMIS9 and the OP apps all support config directories. So there's a config.d. So inside the conf directory, there's now conf.d, and this will get pushed into there, and it would be loaded last. So it overrides all the other configuration options. So I can go ahead and push that out. I won't, but then we could just go ahead and delete that, or we could go and roll that back. So, and that's a really important thing. We can roll that back. So we can reverse the change. So really powerful capabilities. Lots more that probably needs to be talked about here, but I want to move on to some of the other features. And I think we've already looked at that activity, but oh, there we go. So the other thing is we just keep logging all of that status so that you can keep an eye on it, and it's available there all the time, and it's updating all of the time. So let's jump over and have a look at OP charts. And I'm logged into OP charts on the master. So I'm seeing nodes from all polars, right? So I've got three, we saw before that we've got 3 polars, including locally polled nodes, and that we're bringing in data from different polars. And as far as I'm concerned, I don't see any of that. I'm an operator, I'm using OP charts, not relevant to me. We're going to have a look down here at Magni. Magni's one of our servers that runs and is a very important little server to us. And we're looking now at a very powerful new feature called the event history. What happens is all the event history is pushed up to the node, to the master. This isn't an event log, this is the event history. So it's a really powerful capability that we've leveraged in NMIS9 and OPHA, and we get that data from NMIS9, we get it onto the master, and then make it available here to view in OP charts. And that full event history is available in the database, and these things aren't active. And this is the recent history of what's been going on this node. So you can see that it's had some basically CPU things, but they've resolved. The incident level is at, and they're not active anymore. But that was the history, and that was in the past. And we can see here all of the details of this node. We can do a topology diagram. We can see the active links and so forth. This actually runs a VPN, so you can see it's got a VPN. Open VPN, so it's got a few subnets there that we're talking to. And let's jump over and have a look at the performance graphs. Again, all of this node is being managed by a polar, and all of these graphs are just coming through, through API calls from the polar. When we don't know, we're just sitting on the master, looking at the master, just accessing all the data that we need to access. And then we can go and click on our node health, and we can go and look at whatever detail graphs that we want to see bigger. So again, just really easy to use, very straightforward, transparent to the users. We have top N. So when we're looking at top N, this is top N from all of the nodes on all of the polars. So we're no longer just looking at top N. Well, we now have it for working for all of the nodes. So again, you now get full visibility of your entire network. Inventory is the big feature I wanted to show. So what we wanted to do is, let's say we wanted to find all interfaces that have a certain description. So we're going to look for the word connection. So we're going to go in and find the description, which includes the word connection. And we've got something, and that's great. But now we're only interested in things that are of type Ethernet. So we're going to do ETH. So we just want to do a partial match. So now we've done a 2-part query, very, very simple. We've got our first part. Our first part was actually connection. Our second part was was a regex, and that's automatic. We automatically do regular expressions. Regex is really important to understand when you're using regular expressions. They're wonderful and powerful. They're also very easy to use, and they're very simple. And what they do is they give you partial match. So when you say regex match, you're doing a partial match. So this is just like doing a partial match contains, what we're doing here is saying, does this contain this? But you could put really complex, beautiful, rich regular expressions in there if you wanted to. But basically, we've gone through all of those interfaces that were there, and we've gone and filtered them all out, and just reverse that. Now we can look at all these Ethernet ones, and we've got 1,100 entries, really responsive, really easy to see all of that data, and we go back to the full length. So in addition to interface information, we've now got all of the inventory available in exactly the same way. So you can see all of the inventory for all of the nodes. So let's go and have a look at CDP neighbors, because that's a common thing that people like to do. So here's our CDP neighbors. This is the CDP neighbors for all of the network. All right, so we're looking at all of our nodes, we're looking at the entire network, and we can see all of the CDP neighbors for everything. And we've actually got 383. So we can, and then we can now filter that. So we can do a search on neighbor version. I don't know. They're all going to be the same, I think. So let's look for that neighbor version of this number here. It's probably a MikroTik router or something. So there we go. We've got these neighbors. These are the neighbors that we found. The neighbor platform is a T41S. I don't know what that is. But there we go. We found this remote node. And that's the inventory feature. Very, very powerful. And that's where you find interfaces now. We can look at the status of all nodes. So this is the status of all incidents and possible things going on this environment, all pushed through to the master, all available to filter. And again, I won't go through all the details of that filter. So that's concluded our little quick demo of our capabilities in our new wonderful master servers, which are delivered by OPHA using all of that wonderful data from NMIS 9 and making it available on the master server. There's some capabilities there that are really, really key to improve your operational environment and get the data to the people that need the data. If you've got any questions about anything that you've seen today, please feel free to send an email to contact@opmantic.com, and we'll be happy to help you out with understanding more about it. And if there's anything I can do, you can feel free to reach out to me at keiths@opmantic.com. Thank you.